Hi folks, in today's video we're going to be talking about electricity, the electrochemical series and reduction reactions. Okay, so here we have a couple of diagrams. This little diagram over here is an electrochemical cell. Now, electrochemical cell is a device that can make electricity. Two or more of these cells joined together make a battery. A simple cell can be made by placing two different metals in something called an electrolyte. Now, what is an electrolyte? An electrolyte is a conducting solution that contains ions and it completes the circuit. That's the purpose of the electrolyte, is to complete the circuit. You can make slightly more complex circuits by using two different metals in an electrolyte, as you can see from the little diagram. You've got copper sulfate and a copper electrode, and zinc sulfate and a zinc electrode. Now, as I mentioned earlier, an electrolyte is something that completes the circuit. If you have a look as well, we've got this little diagram that says salt bridge that can also be called an ion bridge. Now, what is an ion bridge? An ion bridge allows ions to move across it from the copper sulfate or the zinc sulfate to each other. It allows that flow of ions. And a little note at the top, so electrons move through wires and ions move through the ion bridge. So the electrochemical series places metals in order of their ability to lose electrons, so how likely they are to lose them versus least likely. Metals higher up in this series are more likely to lose electrons than metals lower down. So for example, magnesium is more likely to lose electrons than copper because magnesium is higher up in the electrochemical series. What does that mean? The electrons will flow from the metal higher in the electrochemical series to the metal lower. Let's try some examples ourselves. So go to your databbook and you want to go to page 10 because that has the table that's very similar to the one that we're looking for. And let's have a look at the four examples that we've got. So we've got copper and aluminium. So aluminium is higher up than copper, so electrons will be going from aluminium to copper. If we move down to iron and magnesium, magnesium again is higher up, so they'll be going from magnesium to iron. We've got gold and zinc, so zinc is quite high up and gold is relatively at the bottom. And then last but not least, we have nickel and we have tin. So nickel is just in front of tin, so it's just higher, so the electrons would move from nickel to tin. What I've just done there is something called displacement. So when your metal higher up donates electrons to the metal lower down, it's called a displacement reaction. And then here we have silver and zinc. Zinc is higher up, so it's going to donate electrons. If you have a look, you can see that there's electrons available to be donated. And then if you have a look at your silver accepts those electrons from your zinc. Moving on, these reactions have fancy names that we can use to refer to them for future. So during chemical reactions, if there's a loss of an electron, then it's referred to as an oxidation reaction. And if there's a gain of electrons, it's referred to a reduction reaction. So usually we think of an oil rig, where oil stands for oxidation as loss of electrons, and the rig stands for reduction as gain of electrons. Now, we're not asking you to be able to memorise these off by heart, so again, if you grab a data book and you want to go to page 10 at the end, you will see that we have the electrochemical series, which is the reduction potentials, and reading from left to right, so going this way, they have the reduction reactions, and then going from right to left, you have the oxidation reaction, so you just flip them from the data book, and that's how you're able to identify which one's which. Let's do some examples. So we're going to identify the oxidation and the reduction, and we're going to write the equation for both. So out of iron and zinc, zinc is higher up, so zinc is going to be the oxidation reaction. So we've got zinc, so we need to flip our equation on page 10. And what does that mean? That means that iron is going to be the reduction reaction. So what you would do is you would just write it as is from the data book. Like so. I'll do copper and aluminium before you can try gold and silver yourself. Aluminium is higher up, so therefore it's going to be the oxidation reaction. So we would flip the equation round and write it as it is. And then the copper is going to be the reduction reaction, so you would just write it exactly as it says from the data book. So feel free to go and have a shot at the gold and silver reaction. Again, use the databook on page 10 to help you with this question. Now these reactions can actually happen at the same time. They can happen simultaneously, and what that means is that we call this a redox reaction. Ion electron equations, so the equations on page 10 of the databook, can combine to form an overall redox reaction. The most important thing here is the electrons must cancel before you combine the equations, so you may have to times some of them by different numbers to get those electrons to cancel. So let's have a look at an example between magnesium and copper. So we've got the oxidation reaction written down and we've got the reduction reaction written down. So we need to check that the electrons cancel. So on the oxidation reaction, we can see that we have 2 electrons on the right hand side of the arrow, and on the reduction reaction we have 2 electrons on the left hand side. Now they cancel, so what that means is I can just score them out and rewrite the redox equation. So underneath we just simply take everything, so we've got magnesium, we've got our copper, then we have our arrow, we've got our magnesium after, and then our copper. And that is your overall redox equation. Here we have another example. So on our oxidation we've got 3 electrons, and then on the reduction we've got 2. Now they aren't the same, so we're going to have to times them to make them the same. So what we're going to do is we're going to make them both 6. What that means is we times the oxidation reaction by 2, reduction by 3, so rewrite it. So we're going to have 2 aluminiums, 2 on the other side, and our 6 electrons, and then for our reduction we're going to have 6 hydrogen plus our 6 electrons and your 3 hydrogen on the other side. And because our electrons are now 6, we can cancel them, which means we can rewrite it to have aluminium, your 6 hydrogen, your arrow, your 2 aluminium, and your 3 hydrogen at the end. Oh, that should say gas, sorry. And there we have it, your overall redox equation that you've had to times up to try and get the electrons to cancel. And that is oxidation and reduction and redox. It can be quite a tricky concept, but please don't forget to use the databook on page 10. We're not asking you to memorise them, just make sure that you remember reading from left to right as reduction and then from right to left as redox.